Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in just about any college mathematics course, please consider subscribing, checking out our playlist, watching videos, liking, commenting, sharing those videos. Those are all really simple interactions that you could do that will help us grow, and we would greatly appreciate it. Let's get into the current video. I want to talk about how to actually read an advanced math textbook, whether this is for self-study or it is for a specific course that you're taking. How exactly does one read that? Because certainly reading a math book is a far different experience than reading a history book or a philosophy book or just any piece of literature. So let's go ahead and talk about it. Now, one thing, let me kind of get out of the way. What do I even mean by the word advanced in the context of an advanced math book? I'm not talking about an algebra book, say like for intermediate algebra, and I'm also not talking about, say, a research level text, say that you'll study as a postdoc, right? So somebody's like dissertation, right? I'm talking about essentially a book at the level of a junior to senior level undergrad or perhaps a beginning graduate student. Chances are, if you are beyond a beginning graduate student, you kind of already know what to do. This video might not be for you. It could be, but I think this is primarily geared towards those who are like moving on from like the calc sequence to some more advanced courses, or perhaps beginning graduate school. Again, sort of at that sort of level. So again, how do I self-study, or how do I read a book in a specific course? Now, first things first is let's talk about sort of like your academic background. Now, you should, if you're going to read a math book, you should have a fair amount of mathematics under your belt, and so you'd want to choose a book certainly at an appropriate level. Again, let's say you are an undergraduate student and you're getting ready to take your first, or you're going to take your first analysis course down the road fairly soon, and you might have a little bit of mathematical experience. One textbook that is an absolute classic in the field of, say, real analysis is Principles of Mathematics by Walter Rudin. Okay, this is a fantastic textbook. It is also very challenging. And one thing about this book is it is very dense and it's very concise. It does not have a lot of explanations. It has a lot of gaps for you to fill in. It's a fantastic book, though, right? If you can work through it. But what I would suggest is, let's say, if you are in that, sort of academic at that level where you want to say your self-study and analysis book, is you want to say pick something more along the lines of like, say, a Wade or a Thompson, Bruckner, and Bruckner, something along these lines. And what you might have to do is either ask for recommendations, whether it's just, searching online, say, what's a good intro analysis book. Ask your professors if you're at a college, or maybe you just go on Amazon and you buy half a dozen books and you just kind of, gather some resources, and then you kind of flip through it and like, okay, well, what's appropriate? Certainly, if you are an undergraduate, this book, Real Analysis by Foland, is completely inappropriate. This is a measure theory textbook. Okay, this is what you will use probably not even your first year of graduate school. This would be sort of your beginning PhD program real analysis course. So this is a very difficult textbook and not one for a beginner for self-study for analysis. Hopefully you have some experience of reading math books. If not, then you might want to start at an easier level, like pick something that is already familiar to you. If you've gone through the calculus sequence, maybe you pick something like pick a different calculus book, one not the one that you used for your courses. Like maybe you use Stewart in your calculus sequence, or pick something else like the Thomas textbook, or even the textbook that I have published, and just try to go through, even if not the whole thing, just maybe pick a couple of chapters and just try to read through it, just so you have some experience of reading some mathematical books. And again, I'll talk about sort of the method that you'd want to use for doing that here in a few moments. But again, choose a book that is appropriate to your academic level, and also pick something that's, if you've gone through math textbooks before, you might be able to pick something that is a little bit more sophisticated. But again, it's all dependent on where you are academically. Resources. So one thing that I recommend, if you are going to, let's say you are going to go through Rudin, right? You're going to go through Principles of Mathematical Analysis by Rudin. Well, it's a good idea to, have some other books on standby, have some other books to use as supplementary resources. And you can get quite a few books on, again, Amazon for fairly cheap. Get used copies, get older editions, Dover books. Those are the paperback books that you can get for super, super cheap, like under $10, probably even for new, and significantly cheaper than that for used. But what I would suggest is maybe have, a good 5, 6 textbooks that you are going to use. And again, when I go through kind of the method of how you want to read one of these, I'll explain how and why you would want to have a stack of textbooks. But kind of start gathering books prior to wanting to go through a specific one. If you're at a college, then ask your professors and just stop by their office and say, hey, I want to self-study analysis or algebra or topology or group theory, whatever topic is what you're interested in, and say, what books do you recommend? What websites do you recommend? What kind of resources do you think I should? Do you think I'm even have the ability to do that, right? If it's somebody that's gone through the calc sequence and they came to my office and said, hey, I want to learn group theory, or I want to learn Gauss theory, what book should I start with? And I would probably say, well, maybe you might want to go through some basic abstract algebra before you start Gauss theory, right? Or some basic analysis before you jump to measure theory. So they can have a good idea of whether or not you are academically prepared for going through that specific topic. But again, talk to your professors. And for one, they'll be super excited that you want to learn more math, and they'll probably have plenty of recommendations for you because they also went through those topics throughout their academic career. Okay. You could also use text in a related field. For example, if you're going to go through an analysis book, it's probably a good idea. I don't have one handy here, but maybe pick up a book on set theory, pick up a book on logic, pick up a book on topology. Have some supplementary books or resources on hand that you can look things up. Like, for example, throughout an analysis book, you're going to use a lot of set theory. You're going to use a lot of set theoretic ideas. And while some of these books will have some set theory in them, it'd be a nice idea maybe to have a resource where you have a whole book just dedicated to that subject, because then it'll be much more of a complete resource. So maybe have some additional resources on related topics. There are plenty of websites out there that you can use for resources in addition. For example, one website that I used when I was in grad school, if you go to Google and you type in ask a topologist, or you could probably even type in like ask an analyst or ask an algebraist. Those are forums where people will just type in a question, and then you've got a bunch of people, I don't even know who they are. I don't know if it's grad students or professors at a college somewhere. I haven't used it in a while, so maybe they've updated it and you know who's responding. But people will answer questions. Like if you have a specific exercise and you're not sure about, type it in there and say, how do I approach this? Or pretty much whatever you're looking for advice on, type it in there and you can go ahead and get an answer. If you're doing something computational, certainly Wolfram Alpha is a useful tool. but use the internet. And another thing with the internet is you could probably type in just about any mathematical textbook, type in the title and put PDF after it, and you'll probably get a variety of editions of that coming up. So you don't have to always buy these books. You could just search for, Introduction to Analysis by Wade, type in second edition PDF. When the PDF pops up, then just save it to your desktop, and then you could have a whole library of resources, a whole library of books in PDF form on your computer that you could look up. Personally, I feel like books are more useful, and personally, I would rather have a whole stack of books rather than a whole bunch of PDFs. But hey, PDFs are free, so you do you. All right, now with that out of the way, let's talk about the method. How exactly, with all those things in place, you've got the textbook at the appropriate level, you have some experience reading math books, you've got a stack of books, you've got PDF saved to your computer. I've got all these resources in place. Now let me actually go through and read one of these things, right? So let's say I'm going to go through Rudin, Principles of Mathematical Analysis. Well, what I would suggest doing is, before I suggest anything, just know that this is probably going to be a slow go when you read through this. It's going to take time, it's going to take a lot of work, it's going to take a lot of effort on your part to read a mathematical textbook. So take your time, and again, maybe it takes you a day to get through a page. Something more dense like this, as opposed to, some of these books you might be able to get through a section or two in a day. This, sometimes it might take you a day to get through a page, and that's just kind of the way that it's going to be. Again, it's subjective. It depends on you as a person, your academic abilities, your academic background, the book you choose. There's lots of variables there. But basically what you're going to do is you're going to start going through, and you're going to, so let me just kind of pick a random section here. I guess not super random, I kind of pick, let's see, the beginning of, just something that I can kind of talk about like this, these other books as well. Let's say I was going to start at, Cauchy sequences, right? So I'm going to read the section on Cauchy sequences. So that's the title of this little subsection here. And what I would do is I would read through, and I would read every single word on every single page. So I would just start here on Cauchy sequences, read the definition, read it multiple times, really try to absorb what exactly it is trying to say, take notes on it, but try to read through every single word. The denser the book, the more important every word is, because that author put that in there for a reason. He's not just going to, tell you about his life story, right? He's going to tell you about specifically the mathematics that he wants you to go through. So go through every single word, every single line, every single symbol, and try to understand exactly what he's saying, and fill in gaps too. Fill in gaps for every little thing within each proof, for example. And these little blurbs where he has just, let me see, let me turn it around here. Every little, comment and things like that, read those as well. So go through the whole section on Cauchy sequences, read everything, take notes on it, fill in gaps, fill in explanations, and try to explain where everything comes from. Every single line, where did this come from on the proof? Why does this follow from this? How is this related? Go through everything. And then, once you do that, before you even go to the exercises, or I guess you could go to the exercises, what you want to do is you want to read that exact same topic in multiple other books. I only have 2 with me, but if you've got another, 3, 4, 5 books, whatever, read that exact same topic in multiple books, because you're going to get the perspective of different authors explaining the exact same content, and that is going to really kind of fill in gaps, and you're going to, each author will, motivate it slightly differently, but they'll give the same definition. So there's going to be overlap, of course, with the content. They're probably going to prove roughly the same theorems. They might prove them slightly differently, which is a really good thing that you should read through their proofs. This book might have a proof of a theorem that has a little bit more wordy than this one will. So this one, if you're trying to fill in gaps, this one might do that. And try to make sure that you go through every single topic or every single word in each of those different books, right? And because, like I said, you get different authors' perspective explaining the same thing, right? If you're doing a self-study, it's just you and the book. And so having additional resources will be a huge benefit to trying to understand each individual topic. Okay, so read the same topic read a topic in your primary book, and then go to your additional books and read the same topic. And a lot of times, what's useful is to have your supplementary books at a slightly how do I want to say it? I'll just say a lower level, but like if this is sort of like beginning grad school, advanced undergrad, this could be, maybe slightly under that, like definitely an undergraduate textbook, because usually the lower level books will be thicker. I mean, look at the comparison between, Rudin on top and then Thompson, which is directly beneath that, and then Wade beneath those. See how this one is significantly thicker because they're wordier, and that is going to be useful for self-study to be able to just have more content to read, because then there's less stuff that you have to fill in. And also there'll be like little comments and things that the author will say that, will be very, very useful to read. Okay. Work the exercises. Of course, I think that's, that should be a no-brainer. And work as many exercises as you can. Once again, the exercises in this book are going to be more difficult than the exercises in this book. So work exercises out of both. Work exercises out of maybe the easier books first before you get to maybe your primary text. That would again give you some experience, and maybe, there'd be some significant or some overlap in the exercises. Maybe this one will have easier versions of ones in this book. But again, the more exercises you can do, the better. Just reading it isn't really going to teach you the mathematics. It's going to kind of motivate the concepts, and then when you do the exercises, that's when you're going to actually learn the material. And just the more exercises you can do, the better. And so having those supplementary texts gives you additional exercises, and again, at a variety of levels as well. And usually the more rudimentary texts will not only have simpler exercises that you can work through, just so you can kind of get started and start actually working through these, but it probably usually will have more as well. So work through lots of exercises through your supplementary texts, and then let's go to the primary text and work those exercises. One of the sort of difficulties with having, again, more of an advanced math book is you are not going to have answers in the back of the textbook like you did in your calculus book. In the back of your calc book, you are going to have, if you use pretty much any book on the market, you're going to have, let's say, the answers to the odd exercises in the back, and then you're going to have the even exercises that you are just going to, have to ask your professor how to do. Unless you use my book, of course, you've got most of the answers in the back. But even then, you might, here's a complicated integral, and the answer is 7 pi. Great. What if I don't know how to get 7 pi? How do I then do it, right? That's just knowing that final answer doesn't necessarily teach you how to do it, but that's where, say, solutions manuals could come into play. Well, a book like this generally is not going to have that. It's not going to have answers in the back. It's not going to have solutions manuals. This is where the internet is going to be a fantastic resource. The more famous the book, such as this one, you should be able to go to Google and just type in, you could either type in like principles of mathematical analysis solutions, or you could type in the specific exercise and say, and just hit enter, and you'll probably find a forum where somebody asked the question of how do I do this exercise, and here's the solution. Anyway, the internet should be a really valuable resource to finding solutions to exercises in these books. Just a couple other quick things. Make sure you're taking notes. Keep a running list of the theorems, keep a running list of the definitions, and routinely review those because those are, the building blocks of the theory, and they will also be things that will be used throughout subsequent sections and subsequent proofs. They will, rely on those ideas to prove other things, and certainly the definitions is the language of the material, and so you're going to have to know those things in addition. Other than that, I think that's pretty much all I can think of at the moment. But so there's kind of talk about where you should be academically. Pick a book at the appropriate background or at the appropriate level based on your background, and then also have a variety of resources. Okay, so those are kind of things that you should kind of put into place, and then when you actually go through it, read everything, use supplementary texts, work as many exercises as you can, and just know that it's going to be slow going. If you have any suggestions or comments about how to read an advanced math book, then please feel free to comment below and say what worked for you, equivalently maybe what didn't work for you. But if there's anything that you can think of that could help somebody else, feel free to comment below. Otherwise, thank you for watching, and please consider subscribing.